Okay, so y'all wanted me to make a video that explains how we solve these systems of equations that were given in electrical engineering, looking at circuits, and how we put them into MATLAB and how to solve them, have it solve them for us. So I've made some slides, and the final slide shows the MATLAB code, and the rest shows the idea behind it. So right here we have, this is the idea that the professor wanted us to use. So we'd come up with some matrix M and some matrix V, and that would come from the circuit. And then we have this unknown vector I that we're multiplying by M to get V. And then we have to isolate I by taking the inverse of M, and that would go to the other side of the equation. And I don't really like this method because you guys are probably not that confident with matrix vector multiplication, let alone taking the inverse of a matrix, because this is kind of an odd thing to do to begin with, taking the inverse of a matrix and it's not obvious what's happening. So I'm going to show y'all a different way that I prefer using on the next slide. It's called using the reduced row echelon format function. And I think this is kind of makes it a lot more obvious what's happening when you're putting it into a matrix and when it's solving. So up here we have just the three equations in a generic format with 12 known constants that you'll supply, and then we have our three unknown variables, I1, I2, and I3. And all that we're going to be doing to make this matrix is to get rid of the i's. And then we're just going to get our matrix that is 3 by 4 in the case where we have three unknowns and three equations. And in general, it'll be of size, it'll have the same amount of rows as it has unknowns, and then one more than that columns. And so, but I like this better. What the RREF function, all it does is it's doing on the computer exactly what you'd do by hand if you were solving this, where you'd first you'd multiply, let's say, the second equation by some amount, and then you'd subtract it from the first one in such a way that it gets rid of one of the variables, say I3. And then you do the same thing to another equation. So you generate two equations that only have two unknowns, then reduce it so you can solve each one. And that's exactly what RREF does, but it's done by the computer, so it can do it in less than a second rather than it taking like 30 minutes or however long it takes for however complicated of a system of equations you're given. So this is the method that I'm going to show on MATLAB. So this example just came from homework 2. So our unknowns are I1, I2, I3. This is a mesh analysis problem. So our unknowns are currents. And our equations come from taking the circle, and then across the entire circle, the sum of the voltage is 0. So our resistances and this voltage is given. Those are our givens. And we're searching for these currents. So this is how we generate the three equations, right? You should all be comfortable with this. This isn't MATLAB stuff. This comes from the circuit around I1, VS1. It's just how the mesh analysis works. But this isn't actually what we're putting into MATLAB. We need to put it in the form that we saw like this, where our I1s are all separate, and they're all being multiplied by a single number. So that's exactly what this is. Just very, very simple algebra to get it from this step to this step. One thing, it doesn't matter at all if you keep this as R1, you keep it symbolic, or if you just put in 5 ohms, which is the value, or this at 25 ohms and this at 85 watts, and then this would just be like 30 ohms, negative 25, negative 5. Some people probably like that better. Do as much by hand as possible, or make it look neater, or more obvious that these are the known values and these are the unknown values, just by putting in the actual numbers. It doesn't matter at all. I'm keeping these as in their symbolic forms, just so I can also show you what it's going to look like when we put it into MATLAB, because you can do the exact same thing in MATLAB where you either just put in the values or you keep it symbolically. So going over to MATLAB, code's over here. I put my command window over here. Typically it's at the bottom. I just did this so you can see everything. And going by line by line, we have CLC clear, percent, hash, okay, no, TPS. This is just generic MATLAB stuff you don't have to worry about. CLC and clear, these get rid of any tabs that you have open, or and it clears the command window. And then this one, there were some lines that made it look like there was an error on those lines. I was getting red squiggles, so I just included this and got rid of the red squiggles. And so this is what I was talking about with, you can either keep things symbolically or you can just put in the numbers. So here I'm keeping things symbolically. We're making this variable called VS1 and we're putting in 85. And for the rest of the code, whenever it sees VS1, you can just think MATLAB is going to substitute in 85. Same for R1 through 5. And a note about these semicolons, all they're doing is suppressing the output. So what that means is if I did not include this, over in command window we'd see this, it'd just say VS1 equals 85. We don't need to see that because we already know what VS1 is. So I just suppressed that. Put all of them in here, and here we come to our matrix, which is exactly like it should be right here, symbolically put in. But once again, if you want to, you could just put 30 here. You could do all the math on your paper and then put 30 here, put negative 5 here, negative 25 here, 85. It's completely up to you which way you want to do it. So formatting on MATLAB, you have to start a matrix, begin with an open bracket, then you put in values and you separate them by commas. And then at the end of a row, you'll put a semicolon. So this semicolon isn't actually for suppressing. This semicolon is to mark that we're starting a new row. Press tab or press enter, and then new row. Then our final row, semicolon, close bracket to stop the matrix, and another semicolon to suppress the output because we don't need to see this matrix. So our solution is just as simple as taking REF of the matrix. This is a built-in function in MATLAB, so it's easy. We're going to store this value, which is a matrix in itself, and we're going to place that into a variable we're naming solution. And you can see I didn't suppress this, so it'll show up in our command window. And this is what an REF matrix looks like. So there's still equations, but they're solved equations. We have 1 I1, and that equals 5.75. 1 I2 equals 3.01. 1 I3 equals 2.45. So these are our answers right here. Yeah, so if you just want to go this far, you want to stop, you could make this as simple as 2 lines of code if you did it this way. And you didn't want to do it symbolically. It would just be 2 lines of code. I included this other stuff. These are other MATLAB manipulations you can do. So what this does, solution open parentheses colon comma 4, is it's taking the fourth column of this matrix. So this is just to isolate our answers. And so this is actually the output that would be given by, if you did the professor's way, the way he wants you to do, this is the type of thing you'd get, because you'd get a vector out of that. You wouldn't get a matrix. So open parentheses, colon, comma, and then whatever row you need, or whatever column you need, that's what you put in here. So if this was, for example, a 4 by 5, you'd put a 5 here. And then this is just another thing. We named this I. So if we ever want to grab the solution, or the fourth column of solution, we can just use I. And this is for grabbing individual numbers out of this vector. So very easy. I1 is the first one, I2 is the second one, I3 is the third one. So that's how you solve these systems of equations in MATLAB, plus a bit of extra stuff if you want to make it fancy. If you need any help, just contact me in the GroupMe. I'd be happy to answer any questions. All right.